Hello and welcome guys to the next lesson, degrees, minutes and seconds. This whole lesson is learning about, what happens if an angle, like in the real world or, in a worksheet, isn't exactly on a degree. So I had this funny thing, I remember back in year 5 when we were first learning to use protractors, and my year 5 teacher, he put together this worksheet for us, and we all sat down at our desks and we had this protractor looking just like the one on the screen, and we were measuring the angles. And I actually got really frustrated that lesson because it didn't matter how precise I was. And to be fair, I was, probably 9. I wasn't particularly too precise at all, but I was at least trying to be. But no matter how careful I was with the protractor, the angle never seemed to match up exactly with one of the degrees. It always seemed to be like a little bit above or a little bit below. And I remember I asked my teacher, what am I meant to do? Because I wasn't sure, what I should be doing at that point. And of course, his instructions were, as it would be the case for all primary school teachers really, just, whichever one it's closest to, put that down, right? Ultimately, you're round into the nearest degree. Well, this is the case. In primary school, you do just go to the nearest degree. But we're big boys now in the big leagues, and we start looking at, what actually happens if you do genuinely have an angle that's somewhere in between the 2 degrees. So, degrees, minutes and seconds. We're going to start with our notes, and I'll explain, how we break angles up and, what we do if one of the angles that we're using isn't exactly on a degree, but it's in between. All right, so if you haven't yet, you will need your maths book, pen, calculator. So pause the video, grab your equipment if you haven't yet, and play on. Let's get going. All right, notes for today. This is our heading, and this is it for our notes. Degrees, minutes, and seconds is our heading. Every degree is broken up into what we call 60 minutes. And every minute, hang on, we've got ourselves an error here. Every minute is broken up into 60 seconds. So, once you've got these notes in your book, let's go on, and I will try and explain it over here. Alright, so here I've got the classic example. You've got some random angle that's been written down on a piece of paper. Chances are the teacher just, got it out of a book, or, during the recess break, quickly dropped a page full of angles with a ruler, photocopied them out, and then gives it to the kids. They didn't use a protractor to create the angles. They just used a ruler and drew up some angles. So we're not surprised, I guess, in hindsight, to see that, none of the angles seem to be matching up exactly with, right on an angle. And this is a classic case here where, you line up your protractor on the angle, you go to measure it to see how big the angle is, and there it is, it's stuck, in this case, what looks like right in between what appears to be, let me go super thin here, that's 40, 41, 42, 43, and 44. Right, it seems to be sitting somewhere in between. And as I mentioned, my year 5 teacher, Mr. Harris was his name, by the way. Thought he was so cool. Actually, he was pretty cool, I won't lie. But anyway, jealousy aside, and he would say, whichever one it's closest to is what you put down as your answer. Now, let's look at this a little more closely. Here is my imaginary high-powered microscope. Now, not that it's actually on these cheap protractors, but let's just pretend we had this super accurate protractor that actually included the minute degrees here. I mentioned to you guys that here we have, in our magnifying glass, there's 43 degrees over there, 44 degrees, and our actual angle was going somewhere in between, right? So there was the angle there. And of course, super magnifying glass, there's no angle outside it. All right, so this is what we see under a high-powered microscope. And again, we're going to pretend that we have this really accurate protractor that actually has the minutes on it as well, not just the degrees. So because every degree is broken up into 60 minutes, that means between 43 and 44 degrees, there's actually 60 different divisions, each of them being an extra minute above. This is, as you can see, an extremely accurate and precise angle. If you're measuring to the nearest minute, right, this is very accurate. And like I'm saying, most people that use angles like carpenters and that sort of stuff, they don't even need this sort of accuracy. Going to the nearest degree, even if you're out by a couple degrees, generally will still be okay. But let's say we're in this role where we're need really precise angles. Let's say you're doing laser cutting or something like that. All right, so now that we have this really cool, super accurate protractor and we've got the magnifying glass so our eyes can actually see what's going on, you know, we wouldn't just be saying, oh, well, it's closest to 44 degrees. So, hey, I'm in year 5. I'm going to write down 44 degrees as my answer. Well, while that might be true to the nearest degree, we can have a little more accuracy of our answers. And in this hypothetical scenario, we could see that the actual angle was, it was 43 degrees, and you could then theoretically just go ahead and count, 1, 2, 3, 4, you just start counting through your minutes. Since it's broken up into 60, halfway will be about, well, that would be 30 minutes, and this is a bit more. Let's say it's 43 degrees, and it was an extra 38 of these minutes. All right, that's what it's all about, right? So this is how we measure. If you need greater accuracy than just the nearest degree, this is what you do. You then break it up into the 60 minutes, and then you literally count up, how many extra minutes it is above the angle. So that's how it works. And, not that I'm going to, but every single one of these minutes, see the tiny little gap in here between minutes? Each one of them can actually be broken up itself into 60 separate divisions. Super infinitely small things that we call seconds. And I don't know anyone that needs degrees of that sort of accuracy. But anyway, let's move on and look at our one example for this lesson that's going to demonstrate the sort of questions you're going to have to do. Okay, so the previous lesson we learned how to find a missing side length. So all we're going to be learning to do really is just that skill, but with an angle that isn't exactly, in this case, 36 degrees. It was a little bit above 36 degrees. It was 36 degrees plus an extra 42 minutes above. All right, so we want to find the length of K. Well, the good news is we do everything else the same. First step, label your sides. We have hypotenuse here and opposite here. Once you've labeled the sides, then work out which trig ratio we need to use. O and H belong with sine. So this is a sine question. So we write out second step, our trig ratio. Sine of the angle, which is 36 degrees, 42 minutes. So sine of the angle will be equal to, and make sure you do your fraction in the right order, opposite first and then hypotenuse. So in this case, K over 23.75 centimeters. Okay, so you write out your trig ratio. Final step, are we timed in or dividing for this question? Well, K is on top, right? And remember, top means times. Just think of your alliteration. And so to find the value of K, it'll be 23.75 times sine 36 degrees, 42 minutes. Notice how we haven't done anything different. And truthfully, you don't, right? You've already learned how to find the length of a missing side. If they decide to give the angle with more accuracy, that's no dramas for you. It just means our length is going to have greater accuracy. You just type this in the calculator exactly how it's written. You may be wondering, right, how do I type in this? Well, this is how you type this line into your calculator. 23.75 times sine. Do that all just like normal. Right, and then when you get to the 36 degrees, 42 minutes, the way you type that into your calculator is type in the 36, and then you'll see there's an actual degrees, minutes, seconds button. Looks like this, degrees, minutes, seconds. It's actually, that's exactly what it looks like on your calculator. So to insert 36 degrees into your calculator, go 36, press that button, and then type in 42, and then press the button again. The first number, when you press that degrees, minutes, seconds button, it'll lock that first number in as the degrees. The second number you put in followed by that would be the minutes. And if you had some seconds, you would include a third number, how many seconds it was, and press the button again. But we won't need to get into seconds. Like I'm saying, it's just insanely accurate. Anyway, you type that into your calculator correctly, you press equals, and if you do that, and I actually encourage you to type it in while you're right here, you should end up with 14.19 centimeters. I went to 2 decimal places here because, well, the question said it. Plus, you know, the number in the actual triangle went to 2 decimal places as well. All right, so that's it for your example. That's how it works. Do everything the same. Just make sure you use that degrees, minutes, seconds button. I'm referring to this one right here to enter in the degrees and then the minutes. So pause the video if you need to. Make sure you've got this copied neatly into your books, or at least as neat as you can. Obviously, mine isn't exactly the example to follow. And I've got a couple questions for you guys to practice yourselves. So just the two of them. Pause the video, have a go at answering these 2 questions. Once you're done, press play and I'll give you the answers and we'll see how you go. All right, so the first one over here, you should have ended up with, I went to, the question, technically there was no question here, right? But obviously it was the same. Find the length of the side K. The first one I'm going to round to 1 dp because that's how it was given. But if you went to 2 decimal places or 3, or you rounded its nearest whole number, that's fine. The question didn't tell you what to round to, so you sort of feel free to round to whatever you want, really. And the second one, you should have got 9.26 meters. All right, hopefully that makes sense. If you have any questions, please feel free to leave a comment either here on YouTube or back on Canvas, or email me directly, however you want to do it. Best of luck with your trigonometry, and I'll see you for the next one.